one. So in this experiment we're going to run a series DC motor on both series DC source and on AC an AC source, single phase source. So right now I have wired the motor. This is, as you see, it's a DC motor. I have wired it in series, and I'm going to run it through the variable DC power supply. So I'm going to turn it on now. And we're going to measure the voltage as we increase it slowly. So as you see, I didn't even reach 15 volts and the series DC motor started rotating. So let's put it, for example, at 20 volts, as you see here. And the RPM starts increasing. So this is from a DC power supply. So let me turn it down, back to 0. And now what I'm going to do, I'm going to connect the power supply to a variable, to the variable AC. So this is a variable AC. It goes from 0 to 120 per phase. So of course it has to be a single phase between the neutral and one of the three lines. And I'm going to increase it now. We're going to do the same thing. I'm going to increase it slowly between 4 and N. Okay. And as you see now, we are at 15 volts AC, but the motor hasn't moved yet. Now, of course, when you connect it to AC, there's going to be a mutual inductance, a large mutual inductance. We're at 20 and it still didn't move. I'm going to increase it a little more. I can hear some whining inside the DC motor. Of course, that's from the mutual inductance of the windings. As you see, it's now 50 volts AC and it hasn't moved yet. Okay, now it started moving very, very slowly. But as you see here, 63 volts. Very slow movement. At 70 volts AC, the DC motor, the series DC, started rotating. Still slow. I'm going to increase a little more to 80 volts AC. It's running. It's catching up now, and it's running. As you see, it runs almost very smoothly. But of course at 80 volts AC. I'll increase a little more. The series DC is now increasing in speed. And there we go. Thank you.